What do we got? Okay. Lesson 2. Better box controller. Better box controller meaning better script. We're going to add separate wall jump and ground jump functionality so we can adjust the variables separately. The better box controller will be inheriting from the first box controller we used. And we also have respawn limit script, which will also be inheriting from our spawn limit script. We added a new field here to accept a spawn point, so we can adjust the spawn point in the scene. And we've added one new component, which is a push controller for the pushable cubes. And the pushable cubes are just a regular Unity cube with a rigid body component attached, and we freeze all the rotations so it doesn't roll all over the place when it's pushed. We still have our goals, and they still have the pickup component attached. So again, we start with the most simple of scripts. So a push controller script has a push power. It's public, accessible from the inspector. Doesn't need to be public. We'll leave it as such. And the collider hit. I think this is a message on Unity. I'm not really sure. But this is the function that's called when our required component, the character controller, bumps into something. That something must have a rigid body, and the rigid body must not be kinematic. Kinematic rigid bodies are excluded from the physics engine calculations as far from what I understand is movement. So a kinematic rigid body, Unity will be expecting you to control the movement, and it will not apply any forces to that object. So we check our move direction and make sure that we're not headed in any other direction other than left or right, and we apply the velocity of from our movement. So this hit movement direction is property that lets you know which direction you hit or bumped into the rigid body from. And it's a float value, so it ranges between 0 and an upper bound. So we can use that to, I think it's normalized. So we'll multiply that by our push power to get the boxes moving. Secondly, we inherit from our respawn script, and we've added a few required components. So now it requires the character controller and a box controller to move the character. Let's recap on the respawn script. We have a limit Y, and we cast the transform and the start position. And we have a virtual respawn function here, which we will make use of in the inherited class. So we override the start function, which sets the start position in the base class, and we override the respawn method. So we get the box controller component that's attached. We know it's attached because we require it, and we immediately respawn the character on start. So wherever the spawn point is, the character will be teleported there to start. We do something different on respawn. So if we do have a respawn point, which we left public so we can access it outside this script, this is an instance where we will need that. Then we get the box control and we stop it from moving. and we respawn it. Now here we set the start position in our base class to the respawn points position. And this is the component required by the spawn point limit Y script. This is an abstract class that we inherited from the box controller. I guess we can recap that also, which contains all the movement, updates, and wall and ground jump functionality. So we've inherited from that. Now we require a character controller as before, and we have this field here that's able to draw debug rays, so we can see where our character hit. We get a public accessor, but it's set privately, so only this class can set this variable, which it will be set lower down in the function. We declare a function to enable and disable the controller component from other scripts, which will be necessary, and we abstract Unity's character control hit function, so it must be implemented in any classes that derive from this movable box controller. So this function here that's called by Unity, when we inherit it, as we'll see soon, we'll always call this controller collider hit function and perform these base actions. Here, if we hit from above, we'll kind of send it back down in the other direction at the jump speed. So if it happened to lose any velocity on the way up, we're going to give it all back and send it in the other direction. And for below, we just draw some debug rays. So if you see yellow, that'll be from below, red is above, and green would be from the sides. And here also we slow the character down. It's on its X direction by just a bit, as long as it's touching the wall. So if you're holding to the left and it's touching the wall, it'll continue to move at about that speed. So if you're jumping off, you would get the same velocity. But if you're not holding and you're sliding down the wall, it'll continually lose this X direction. So when you do finally decide to jump off the wall, you'll be jumping off a lot slower than before. So this is the base class. Now on to our quote-unquote better box controller. Here we abstract out the get jump input, which will calculate how long we've been holding down the jump button. This is a change that we've made from before, to where once you press the button, it jumps at the maximum jump speed, and the wall jump did the same. The difference here is once you hold the key down to jump on the ground, you'll jump. You don't need to keep repeating that action. On the wall jump, however, you needed to press the button down each time. So get button down, that's what that does. It means each time you press the button down, it will respawn. Get button means it will continually respawn once the button is held. So in our better box controller, we'll use this in the ground and jump movements. So here we separate our jump on the ground and our jump on the wall. So we have a speed, sensitivity, and max for each. Here we have a few new properties: header and range added to our serialized field. And properties define a few things, just that the they don't perform any actions in your code. They can be read through the inspector to perform different things in the inspector, as used here in Unity. We'll be creating our own property drawers later on in these lessons. Stay tuned. So now we override our ground movement and our jump movement. They're pretty much the same, except we'll be using the function we created above, the static function, to do both jumps, the ground jump and the wall jump. We pass in a reference to our jump speed and a reference to our wall speed. When you add reference to a parameter, what that means, you give the function permission to change that variable that's being passed in. Normally, if, for instance, max speed was changed in this function, it will not be reflected outside of the function. It would be a local change. By adding reference, any changes made to this variable inside the function will be reflected outside the function, particularly in the parameter that was passed in. So if ground jump speed changes, we'll have the value it changes to once it gets out. Then we'll set it to our jump, and we'll reset that value. And this can only happen, of course, if we're grounded. We want to be able to jump. And for the wall, we do pretty much the same as before, and we're checking for the wall speed. And here's our force overridden on collision on controller collider hit method that we call our draw function to draw our debug rays and get our hit. What was that? I think it was a property. Let's make sure. Yeah, just get our hit property and it will be assigned in here. Not where we can tell through any other script where and what has been hit. And that is the box controller. That's lesson 2. We've separated the ground and wall jump variables so they can behave differently. And now let's see some of that behavior. So here's our gizmo for our spawn limit. So if I turn on gizmos here, you'll see all the gizmos. So when we reach that bound, we'll be respawn to this spawn point. We have our pushable cubes. Let's not push that off the edge there, which we need, of course, to grab this piece here. And of course, from before, I'm going to try to solve the puzzles. I may have to change some values in the inspector because it's not always as easy as it looks. Alright, so I got 2 more. And now if I jump off the wall, I just need to hold down the button to jump and to get to the top. If I jump and slide, by the time I hold down the button, if I take too long, I would have lost so much energy that I won't be able to make it to the wall anymore. So it's all analog. And that's it. Cool, so we've added 1 new component and we've upgraded 2 components in this lesson. I'm gonna run again so we can see the debug rays in the scene in the game view here. If we turn on the gizmos, that's one of the things that we also get to see. So you can see every spot that you collide on. The yellows are being shown on the bottom, they're just very faint. So you can tell exactly where you collide if things need to be changed. Cool. So lesson 3, we'll be adding an input manager for mobile interface. We'll be pulling out all the jump functionality into a class by itself, and we'll be adding that into our mobile box controller so it can be controlled and on an Android device for me. And that will be next, the mobile box controller.